Right. So far now what we have discussed is we have given computer the power to see something, to get something out of it, but it cannot do anything until unless it has the power to process it. The data that is coming to the device is huge and it's not stopping. The camera is just sending those data streams to the processors, right? So how do we process those data streams? Those data streams that we are talking right now, the video ones, is quite different from the normal stream that we worked upon, right? Every device has its own mechanism to send those data streams. So computer vision is something which does that data processing for us. It takes the raw streams, something like the color stream, depth, values, voices, and it does something and give us the information which is relevant to us, something like feature detection, motion tracking information, object construction, the visualization, and all. So what is this computer vision or CV? It is very important for us to understand what this computer vision is, because it is a field where you study and you do research on what kind of algorithm, what kind of things we have to do to process the image or the large size of data that we are talking about, to give essentially computer the vision that we kind of have. So it's a altogether a particular field, and definitely we have to understand certain concepts which has been researched in computer vision. So the objective of the computer vision was to get some information out of it, get the visual sense of what we are seeing, what we as a human see, and give that power to the computers. So common algorithms that you normally use to get that information from the basic ones are the age detection, blob detection, cascade classifiers, motion tracking and all, and also histogram. So these are a couple of algorithms kind of things which is there in the computer vision. People have done so many research in those areas to create a sophisticated and very powerful algorithm, and using which we can process our streams and extract those information. If you talk about the age detection, what it does, like we see canny age detection or the Sobel age detection, what it does, whatever the scene, whatever the stream that is coming to us, it's trying to get the information, get the edges from a particular scene. Something like when you're looking at a building, to get the sense of the height and width of the building, if you could have known the edges, you could have easily identified the dimensions. So these kind of operators, these kind of algorithms gives us the power to do those things which is required. Okay. And the blob detection. Blob detection is something where you have some random streams, random information to the stream, but definitely you want to pick out something like an arbitrary shape. The arbitrary shape could be, for an example, if you have a heap of coins and you want to just identify that heap, how big is the heap is, right? So that you can just think about it and process that information for some reason. There are a couple of transformations like Laplace transformation, Hood transformation, Gaussian filters, all those kind of linear filters available to help us in the blob detection. And those are the basic things which we need, and I will be talking about it later, that how can we use those things to create gestures, to implement gestures. There comes the cascade classification. Cascade classification is a form where you kind of create certain patterns, you put them into some kind of configuration, and how does those cascade classification classifiers works? They keep on, matching the coming streams for those patterns and find out the required information. Something like you have the hard-like features where you can create the patterns for eye matching, and you can create several patterns from it. And when you implement these algorithms, what it does, it tries to match the coming input and find out the eyes from it, right? So this is something the cascade classification does. And something similar, motion tracking and analysis, which is essentially actually if you identified something, you have detected some object, then definitely you want to track it as well. So that it is basically done using the background extraction and finding out the relative position of the object which you have identified in previous sequences. So basically the motion tracking and analysis is part where you need for gestures detection and all. There is one more thing which is related to the histograms. Histograms is something which gives you the the distribution of the different data which is available in the streams. Sometimes you need it. Well, again, those are very complex things, and if you really think like you want to implement it, definitely you can implement it, but it's gonna take a lot of time. And we have the people, the people in the industries who have developed the frameworks and the APIs for us, using which we can just simply use those algorithms. We don't need to reinvent the wheel. We can just implement our functionality using those algorithms which has been developed by different frameworks. Some of them which is namely are OpenCV. OpenCV is a very wide group which does, which has provided the implementation for different algorithms which you can use for computer vision application. Similarly, the simple CV, fast CV are there. OpenNI is one thing which is related to the natural user interface. It is an open framework which provides you the functionality to to do the gestures and all. NIT is one thing which is the natural interaction middleware, which works as a middleware between the Kinect or a similar kind of devices and the OpenNI. We can use it that way. Kinect also provides you SDK, which works for Windows, and you have to do minimal work and concentrate on your application, and you can easily create the hand swapping and other kind of stuff which has been provided by default in Kinect. It does provide the face tracking application, face detection API as well. So what do we do? Like, we have the tools, we have the algorithm with us, and we have the input stream. What do we do with that? Definitely we have extracted some information and we want to react to that information, right? So as you can see, now you can control the flow of your application. You can just do a swipe of your hand and you can change the content. You can do a push and you can click on something, right? It's very easy. So these kind of application can be created. So if you look at the screen for how the implementation flow for the gestures works, is you have the stream input with you. What you do next to it is you detect the different body parts like your hand. If you want to implement the hand with gesture, you can have the hand detected, and you keep on detecting it, you keep on tracking it in the next stage, so that you can evaluate the path, like how the hand has been moved from, let's say, left to right, Was there any variation? Was there any significant variations to it? And based on that, you can evaluate and you can determine if it was the gesture which I was looking for. Because it's possible that you are moving your hand but in the opposite direction, or probably in the vertical direction, not in the horizontal direction. Yeah. So essentially what happens in this, you keep on getting the streams, you keep on processing the data, and you are collecting that information from one particular scene, one particular cycle. Keep on accumulating those information and create a gesture out of it. If it is not, then again. But what is essential, what is the difference in this kind of application, this kind of implementation is you are not stopping any movement, right? Something like we have in console-based application or grid-based application, graphical user interface. So in those applications, the user has to do the input, user has to initiate the interaction. But now what is happening, camera is seeing what he has to see. He is continuously seeing those things. He is continuously, it's listening. And we have to extract those input information to us so that we can use those inputs and pass it along to the other external world where the gestures information needs to be used. There are certain points which we need to remember while we implement the gestures. We need to define the body joints and track them. So essentially what we are saying over here is I should be able to identify my, let's say, palm, and I should be able to track it. And then if I am able to track my palm, right, I can evaluate on top of that. So let's say if I say I want to evaluate a lag gesture. So if I have tracked all my fingers and my palm, I can do certain calculation to find out if there's a lag gesture. Lag gesture is something like a thumbs up gesture. There are two things to it. When you are evaluating a gesture, what you can do the algorithmic evaluation, something like whatever the stream that is coming to you, you can process it every time. Or what you can do the pattern matching as well. Because sometimes what happens when you implement the gestures or postures, it is very difficult to create the mathematical logic out of it. It's very difficult. Something like you are doing something with your hand, one hand, and you are doing something very different with your other hand, and it is very difficult to create the mathematical equation out of it, the mathematical procedure for it. So what you do normally, you create the patterns, you record those patterns using the cams, the tools you have, and you save it. And in the real time, when someone is in front of the cams, you just match those patterns. So there are definitely pattern matching algorithm available, but it would be easier to implement once you have a very generic pattern matching algorithm to you, which you can tune to your application. So this is one of the way, but there is a trade-off between using the algorithmic versus the pattern matching, because you cannot have a very complex algorithm which takes time. On the other hand, you cannot save so many patterns that your performance is going down. So you have to choose between those two options. The other things which we should take care is the overlapping of gestures. We should not design such kind of gestures which is kind of contradicting. Like you have one hand in front of you doing something and you are extracting the gesture from it, and you just put some other object or your other hand in front of it, which will be blocking the view, right? This is one form, the blocking of thing. And the overlapping is also like you have two hands doing something else, which can all overlap each other. So these kind of scenarios should be avoided. And value to the implementation. We need to take care of so many things related to the external factors, which could be lightning, because what the camera is saying is passing to us, and depending upon the what is the quality that is coming to us, we have to process it. So it varies with different lighting conditions. And also in the moving backgrounds, we have to consider the situation, and think and design accordingly when we are having the application which is running in the moving backgrounds. That sometimes create problem. So we need to think about those external factors while we develop these kind of application. Then we move on to the challenges that